In this video, we're going to take a look at adding and subtracting radicals. There's a couple things that we need to know before we get started. One, we can't combine them in addition and subtraction unless the indices are the same. And so in this particular problem, we have three terms. That means we have to check to make sure that the index of each term matches the other terms. Otherwise, they can't be combined. So you'll notice we have a cube here. That is not going to be able to be combined with the fourth power or with the square. Now the fourth power is not the same as the one with the square either, and so we may not be able to combine those. However, you can't make that call until you simplify the radicals. So the second thing is the radicands must be the same. Now right now, again, they're not the same, and so it looks like we're not going to be able to combine any of them. However, we have to simplify them first. But these are the two conditions that we need to look at before we can make that call. Let's go ahead and get started on this first one. We're going to go ahead and I'm going to use a different color for each term, and then we'll go ahead and simplify each term. So for the first one, we have the square root of 50x. Well, the square root of 50x can be rewritten as the square root of 25 times 2x. 25 is a perfect square, which is why I picked it. I can bring that perfect square out. The square root of 25 is 5. The square root of 2x is simply the square root of 2x. You can't simplify it any further than that. On the next term, we have the cube root of 648, x cubed. Now, this one might be a little tough, but if you've made a chart that lists all the squares up to 15, the cubes up to 10, and the fourth and fifth powers up to 5, you can check each one of those in the cube column, since we have the cube root, to see if any of those go into 648 evenly. And you'll notice that 216 does. X cubed is also a perfect cube, and so I'm going to put those two together, but then it's 3 times 216. And that's going to give us 6x times the cube root of 3. Finally, we have our fourth root of 64x to the 6. Now the perfect fourth root that goes into 64 is 16, and so we're going to rewrite this as the fourth root of 16, x to the fourth times, and it's 4 times 16, and x squared. And now we can go ahead and simplify that. The fourth root of 16 is 2. The fourth root of x to the fourth is x. And then we have the fourth root of 4x squared. Now, 4 is a perfect square, and so is x. So what we can do then is we can rewrite this as 2x times, and now this is 2 squared x squared to the 1/4 power. Well, if you notice that, then you can bring out these exponents of 2 and multiply the top of this rational exponent. So you'll have, finally, it's 2x times 2x, but it's raised to the 1/2 when you reduce. If you multiply the 1 by 2, then that's the effect is factoring out this 2. But if you bring this 2 exponent out according to the power to a product rule, then you'll have a 2/4 exponent, which can be reduced to 1/2, which means this is going to be 2x times the square root of 2x. This is why I said you had to be very careful about choosing to look at it to say, oh, well, can I get them or not? Well, you got to simplify it first, because if you notice, we have a root 2x out of the first term and a square root 2x out of the second term, now you can combine them. So step 2, now check for the conditions. So we can combine the first and the third. Let's use a different color here. So we can combine the first and the third. In fact, I'm going to rewrite it slightly. I'm going to write it as 5 square roots of 2x minus 2x square roots of 2x plus 6x cube roots of 3. Step 3. Once you're simplified, add or subtract the coefficients. Now, if we can't, and here we can't combine the cube root with anything, it just doesn't match for the index and neither for the radicand for that matter. However, we don't have any coefficients that we can combine. The 5 and the 2x can't really be combined. They're not like terms. And so I put in this fourth option to say, well, if you can't, check to see that you can do this. So if you cannot combine the coefficients, I'm going to rewrite it down here. 5 roots of 2x minus 2x roots of 2x plus 6x cube roots of 3. If you can't combine the coefficients, factor out the radical. So we're going to take this root 2x and we're going to factor that out. And when we do that, the rest of it goes in parentheses. I put that as like a separate notification, but really this is what factoring out means. And so it's really 5 minus 2x, that quantity, times the square root of 2x plus 6x cube roots of 3. And this is in simplified form. So all you have to do is go through these 4 steps and you'll be fine.